Welcome everyone. Today is the second tutorial session in the subject Mechanics of Solids. Today we'll be focusing on the content which was covered in the week 2 of the lecture content. And our main focus will be on truss and the two methods, that is the method of joints and method of sections. So I welcome everyone to this class. I am Sukanya Karmakar. I am a fourth year PhD student in the Department of Civil Engineering at IIT Kanpur. So I have a mixed bag of questions. So let's start understanding the concepts through the questions. Just hang on for a second. I hope my screen is visible now. So let's start without any delay. Let's start today's session. So today we'll be focusing on truss. So, so uh, directly let's start away with questions. So the first question is like my entire motivation will be um, to s- solve questions so that your assignment solving experience becomes easier. And if you have any doubts in the assignment, in solving the assignment related to week 2, you can also raise those questions. Maybe we can discuss those doubts as well. So, let's start. So this is tutorial 2, and we'll be focusing mainly on trusts. So I hope my writing is legible. So the first question is, you have a trust like this. So trusts are mainly members which can carry axial forces, that is tension force and compression force. So basically it is a two force unit. And usually, we neglect the self weight in such members because like comparatively the weight of these members is very less. So this is A, this is B. This is C and this is D. I'll write down the dimensions. This is 4 meter. This is again 4 meter. And this is 6 meter. At this point, you have a force of 600 Newton acting. At this point, you have a force of 900 Newton acting. You have to determine the force in the member C, this is E, CE and CD. Find force in the members CE and CD. And I would also like to give you some options. E, B, C, and D. It is 800 Newton. C is for compression and 900 Newton tension. Second option is 800 Newton tension and 900 Newton compression. 900 Newton tension and 800 Newton compression. 900 Newton compression and 800 Newton tension. So your first step will be drawing the free body diagram. So I'm not giving some you time to solve this the first question. Let's do it parallelly. And for the next question, maybe I can give you some time for solving. So your first step should be drawing the free body diagram. Just time for that. So should I draw the free body diagram, or I can also use the method of section? Let's use the method of section. I'll show you why it will be easier. So you need to find out the force in the member, this member CE and the member CD. So uh, what if I solve the force at this joint and get the force in the member CD and CE? Basically, I get the force in the member CD, and then at this point, CD force will be, see, here I would like to mention at a joint. Suppose at the joint D, you have two equations of equilibrium, because at a point there is, what are the two forces of equilibrium? Summation of Fx is equal to 0 and summation of Fy is equal to 0. And there is no, just hang on for a second and check whether I'm recording the session. Yeah, I'm recording the session. So here, the summation of moment is equal to 0. That equation of motion does not have any significance, because you're writing, suppose at this point B, you have the member, the force in the member ED, the force in the member BC, and you have 600 Newton acting. This is point D. So, since you are taking a drawing, you can say the free body diagram of that joint or a point, there is no meaning of the moment equilibrium. So here you have two unknowns, that is force in the member ED and the force in the member DC. So two unknowns, and you have two equations of equilibrium, so you can solve it, right? And here one thing which you will need is this theta, right? So what I'll do, I want to calculate uh, DE, and from that I'll calculate CD. Okay, so let us do summation of Fx is equal to 0. And here I have considered the tension force to be positive. See, suppose this is the member and suppose the member is in tension. So the force in the member will be in this direction. So on the joint, the force will be in the on the joint D. The force will be in the vertically downward direction. So the arrow of the force away from the joint, that denotes tension. And here I have by default I've taken both the forces to be in the tensile direction, and the sign of the answer will sign of the answer will be positive, means the force is in tension. If the answer will come out to be negative, that means the force will be in compression. So here I have considered uh, assumption forces are so force direction thickness, force direction away from joint denotes tension. So it denotes tension. So now let's write down the equilibrium equation. So if, and let's assume force in this direction to be positive, force in this direction to be positive. So minus F E D sine theta minus 600 is equal to 0. So F E D will come out to be minus 600 divided by sine theta. Now, what is sine theta? From this diagram, we can see this is 4 meter. I think so I've not given some data in this question. This is 4 meter, this is 4 meter. What is the location of this point? This distance should also be given in the question. Sorry for the problem in the access, so something is blocking. Yeah. This distance is 3 meters. So tan theta is 3 by 4. So sine theta, let's put, in other words, this is 5 meter. Or sine theta is 3 by 5. So FED is minus 600 into 5 by 3. So this comes out to be 1,000 Newton. And minus denotes 1,000 Newton is in compression. Then using summation of Fy is equal to 0 at, this is at joint B. Similarly at joint D, you do summation of Fy is equal to 0. So minus F E D cos theta minus S DC is equal to 0. So minus because I've taken force in the upward direction to be positive. So FED comes out to be it's minus 1000, right? So plus minus minus becomes plus. Cos theta will be 4 by 5 minus FDC equal to 0. So FDC comes out to be 1000 into 4 by 5 and it's comes out to be 800 Newton. So 800 Newton positive means 800 Newton, 800 Newton tension. So this is 800 Newton tension. 800 Newton tension means this is the correct answer. Let's find out the other number as well. Other number in the sense the force in the member CE. So for the force in the member CE, what will you do? You will write down the where you'll use the method of joints. Like basically writing down the equilibrium equation at a joint means use of the method, um, the method of joint. Basically, we have two methods. So what I'm using here is the method of joints. Hang on for a second. Okay. So now using the method of joint at joint C, like write down the equilibrium equation at joint C. So joint C, this is the joint C. So let's take again force and tension to be positive. So FCE, then FCB, FCB, and 900 Newton is acting in this direction. And you need to find out FCE. So I will do summation of Fx is equal to 0. So minus FCE minus 900 is equal to 0. So FCE is minus 900 Newton, meaning it is 900 Newton and it is in compression. So this is the correct answer. Let's move on to the next question. So the next question is for the truss. Truss is like this. This is one member, this is one member, another member, this is one member, and this is one member. This end is pinned, this again is again pinned. This is A, B, C, D, and E. And you have a force of 6 kilonewton acting here, 8 kilonewton acting here. This is 2 meter. This is 1.5 meter. This is 2 meter. You need to determine the force in the member BC, and DE. Determine the growth in members BC and DE. BC is this member and DE is this member. Again, I am giving certain options. Options are 18.5 kilonewton pressure and 4.5 kilonewton tension. CT 18.5 kilonewton again in tension, 4.5 kilonewton in compression, 4.5 kilonewton in compression, and 18.5 kilonewton in tension. Then 4.5 kilonewton in tension and 18.4 kilonewton in compression. So here again I'll be using uh, the method of, let me use the method of sections, right? So for here, so basically in this number, in this question, I used the I've used here the concept which was covered here is method of joints, and here in this question, I'll be using the method of sections. These two forces in the members have to be calculated, PC and ED. So let's cut a section like this. And let's take the truss, uh, the left hand side of the truss. This is force in the member BC, the force in the member BD, force in the member ED. This is 8 kilonewton, this is 6 kilonewton, this side is 2 meters, 1.5 meter, and this is again 2 meter. And suppose if I take the moment about the point P, then uh, this FBD and FET is passing through the point D. So no moment will be created by them, and I can calculate force FBC. So let's take the moment about point D is equal to 0. Let's consider clockwise moment to be positive. So FBC into 2 the clockwise direction minus 6 into 1.5 plus 2 that is 3.5 minus 8 into 2 is equal to 0. So SBC comes out to be 8 into 2 plus 6 into 3.5 divided by 2. So it comes out to be 18.5 18.5 kilonewton, and since it is positive tendency, so SBC 18.5, so the correct option is B. So let's find out the question number DE. For DE, what you can use, you can uh, BC is calculated in E. So what will be the easiest way of calculating DE? You can calculate SBT. Uh, so you can do summation of vertical force is equal to 0, and let's take vertical force in the upward direction to be positive. So FBD is you're taking the FBD is like this, you're taking its component, so that will be negative into uh, this angle is theta, so cos of theta minus 6 minus 8 is equal to 0, cos theta is 45 degrees, so FBD by root 2 is equal to minus 14. So this is FBD. FBD comes out to be minus 14 root 2. Then if you do summation of fx is equal to 0 on the entire diagram, so FBC plus FBD sin theta plus FBD is equal to 0. FBC is 18.5. FBD is minus 14 root 2 into 1 by root 2 plus FBD is equal to 0. So FBD is minus 4.5 kilonewton or 4.5 kilonewton compressive. 4.5 kilonewton compressive. So this is the correct option. So this is how you use the method of joints, right? Method of sections. So through this question, I displayed the technique of method of sections. So let's move on to the next question. Now, uh, let's take up again a graph. So we are doing question number 3. So this is the truss. So what till now, what we have done, we have taken up simple trusses and we have seen the method of joints and method of sections. Now let's take up a truss and let's see, according to the question, which method is easier to use. Usually, the method of sections in these type of questions where particular members are marked is easier in the sense it's less time consuming. So your truss is something like this. Then connected here, then connected here. This is A, B, C, D, E, and F, G, H, I, K, K. This is 4 feet. This is 3 feet each. 3 feet, 3 feet, 3 feet, 3 feet, and 3 feet. And you have point loads acting at this point, this, this, and this. And the value of the load is 1500. Right. And in the question, it's mentioned you need to find the force in the member HG, HE, PE of the truss. So find forces in HG, HE, and DE. So HG is this member, HE is this member, and DE. So as we did in the last question, you can even use because the method of joints, you can start from the point F and the two unknown forces at this joint F is EF and EF. Then you get your C to joint E, where no, at joint E you can't proceed since there are three unknown reactions. You need to proceed to joint G. Then force GF. There are two unknown forces, HG and GE, and you can solve at that joint, but that will be cumbersome. So let's use the method of sections. So I'll be cutting the section here. So let me name this section A and take the right hand side of the truss and draw its figure. That will be my first. So FGH FEH then sorry, draw this beauty. FEP, this is FET, this is 1500 pounds, and then we have 200 pounds. And this theta is can be seen here tan theta is 4/3. This is theta. Now, the first step, what should be the first step be? Again, we can do, we can take the moment about point E. If we take the moment about point E, then the moment due to the force FEH, FED, and that 1500 pound will disappear because everything is, all the three forces is passing through the point E. Okay. Let's take the moment about point E is equal to 0 and let's take clockwise moment to be positive. So minus FGH at a distance. How much is this distance? This is 4 feet. So into 4, and how much is this distance? This is 3 feet. So plus 1500 into 3 is equal to 0. So FGH comes out to be 1500 into 3 by 4, which comes out to be, I calculated, it comes out to be 1125 pound, and it's positive, means the force is in tension. So FGH is calculated. Then you can do summation of force in the vertical direction to be 0. Summation of force in the vertical direction to be 0. And let's take this y as the positive direction, this x as the positive direction. What I'm doing this, my motive is, see, this force is calculated. Now, if I do summation of Fy is equal to 0, and the only unknown appearing in that equation will be FEH, because FED is a horizontal force. So minus FEH, because its component will be in the negative x direction. So that into this angle is also theta into cos theta, sorry, in the vertical direction, so sin theta, and is picture in the vertically upward direction, so plus minus 1500 into 2, because the two forces at point E and F is equal to 0. FEH is 3000 by sin theta. Okay. Now do summation of Fx is equal to 0. Now you know FEH. Now I want to find out FED. So minus FED, because it's in the negative x direction, minus FGH, negative x direction, minus FEH cos theta is equal to 0. So FED is minus 3000. Sorry, this is FEH. Very sorry. So FED is the unknown. So minus FED, and FGH is minus 1125, and FEH is 3000, basically divided by tan theta. So 3 by 4 is equal to 0. So FED will come out to be minus, pull up my calculator, 375 pound, and it's negative, so the force is compressive in nature. So it is 1125 tension, 3375 compression. So you have to calculate the force in the member HG. HG is calculated. HE, okay, let me plug in the number. 3000 divided by sin theta. Now, sin theta will be, this is 3, this is 4, so 4 by 5. So sin theta is 4, 5, and it comes out to be 3000 into 5 divided by 4. So 3750 pound positive, that is in tension. Tension and receiving compression. So is this question clear? Here I have again used the method of minutes. So in this same math question, now I want you to find out the force in the member CDHI and CH. So this was, let's say, part A, and part B will be the force in the member CDHI and CH of the truss. So CD is this member, HI is this member, and CH is this. So again, you can cut a section here and let this be section BB. Then take the right hand side of the truss and solve the question. So it's very similar. The head is still but straight. So SHI, sorry, now the member is running like this. F, F, C, F, C, D, this is H, this is G, this is F, this is E, this is E, this is C, this is I. Have the forces 1500, 1500, and 1500. Let's quickly take a break of 2 minutes and be back. Till then, you try solving this test. So again, in this question, we'll be using the method of um, sections. So take now, take the moment about point C and consider clockwise moment to be positive. So moment due to force FHC and FCD will not appear in the equation. So minus FHI into 4, okay, plus now there will be 1500 into 9 is force plus 1500 into 6 from this force, because now you are considering moment about point C, plus 1500 into 3 is equal to 0. So SHI comes out to be, plug in the numbers, 9 you get 203 plus 1500 into 6 plus 1500 up to 9 divided by 4. It comes out to be 6750. Again, it is positive, uh, meaning the force is adding, meaning this force is in tension. So let me see. Okay. And let's see summation of force in the y direction will be 0. Again, let's consider force in this direction to be positive. This is positive x and y. So, and here we consider this angle is theta. So even this angle is theta. So this angle is theta. So tan theta is 4 by 3 sine. So summation of force in the y direction is 0. So y direction is F H C sine theta. Component is in the downward direction, that is negative. FHC is this force, right? Downward direction, this source, I'm considering this force, its component in the downward direction, so that is negative. I'm removing this component, otherwise it will be confusing in the notes. So this and any other force appearing, any other force is these forces. So minus 1600 into 3 is equal to 0. So FHC is 1500 into 3 with the minus sign by sine theta. And how much is sine theta here? Sine theta is 4 by 5. So minus 1500 into 3 into sine theta is 4 by 5, so 5 by 4. So this comes out to be 1500 into 3 into 5 divided by 4. So it comes out to be minus 5625 pounds, minus meaning the force is compressive in nature. Then do summation of Fx is equal to 0. So there we'll have minus Fhi minus, because the force is in the opposite direction of this x. It is in the opposite direction. So Fhi, then again minus Fhc cos theta, then will be again FCD, again in the negative direction. So minus FCD is equal to 0. So plug in the numbers. Hi is minus 6750. HC is minus 5625, and cos theta is again 3 by 5. Cos theta is 3 by 5 minus FCD is equal to 0. So FCD comes out to be minus, the answer will be 675, sorry, 6750. So 10125 pounds. Okay, so this when I'm plugging the number, this hang on for a second. Here, while plugging in the numbers, I made a mistake. Here, SHC is minus 5625. So if you substitute it with the sign, so this will be plus. So the answer comes out to be 6750 times 260 kilograms to 25. So 3375. Yes, this is positive, means this is tensile. This question is done. Let's pick up a different question. Again, I'll be giving you a trust. You'll have to find out the force in that. So the trust is like this. It's U, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. This is unhinged. This is a roller. Here you have a force of 2 kilonewton. Here you have a force of 5 kilonewton. Here you have a force of 3 kilonewton. And again a force of 2 kilonewton. 16 meter is total. And there are how many panels? 1, 2, 3, 4, 5, 6, 7, 8. 8 panels. Panels meaning AB is one panel, BC is a different panel. So 8 at the rate 2 meter. So, sometimes this is another way of dividing the distance. Length is 2 meters, this length is 2 meters. You need to find out the forces in the member CD and CM of the bridge. CD is this number and CM is this number. So how will you find out the four simplest numbers? Just maybe we can briefly pause for 2 minutes. Please think about it and then you solve the question. So method of joints will be very cumbersome. One thing you can do, you can cut a section like this. The first thing which you can do is you can calculate the support reaction at, uh, let's say, see, at I, it is a roller, so you'll be having a vertical reaction. So let me draw the thrust once again. This being a roller joint will have a reaction at I, and at A you have a hinge joint, so R A vertical, R A horizontal, and you have vertical force of 2 kilonewton at point C, at 5 kilonewton at point E, at S you have a force of 3 kilonewton, at G you have a force of 2 kilonewton. This R A H is 0 because summation of Fx is equal to 0. If you use that condition, there are no horizontal force acting on the structure, so RAH is 0. Now let's calculate RAV. For that, the easiest will be taking the moment about the point I. Then Ri will disappear in the moment equation. So let's take moment about point I is equal to 0 and let's take clockwise moment to be positive. So RAV into 16, okay, minus 2 into 6 minus 5 into 4 minus 3 into 3 minus 2 into, that is what I am doing, 2 kilonewton force is at a distance of 4 meter. See, this 2 kilonewton, this 2 kilonewton force is at a distance of how much? How many panels are there? 1, 2, 3, 4, 5, 6. So 6 into 2 is 12. It is at a distance of 12 meters. And this 5 kilonewton force is at a distance of 1, 2, 3, 4. 4 panels means 8 meters. And this is at a distance of 6 meters. So this is equal to 0. So from here, RAV comes out to be into 12 plus 5 into 8 plus 3 into 6 plus 2 into 4 divided by 16. So force is 5.625 and this is in kilonewton. Positive means it is in the vertically upward direction, whatever I have assumed. Then uh, consider this section AA, which I have drawn, and consider the left hand side portion of the truss. That is why, since I want, by using the method of section, I wanted to use the left hand side part of the truss. That is why I found out the reaction. Otherwise, if I wanted to take the other part of the truss, I would have found out RI, that is, because I would be drawing its free body diagram. It's A, N, B, C, F, N, M, F, C, M, F, C, D, sorry, this is F, F, C, O, this is F, C, D, because this is the point D, this is the point O, this is point M. Now what you have to calculate is FCD. F for calculating FCD and okay, so how many unknown forces are there? You are cutting 1, 2, 3, and 4 members. So 4 unknown member forces plus this reaction RAB, which you have found. Okay, this you have found. So how will you do it? You can take the moment about point A. Then FNM will disappear. FCD will disappear. You have FCM and okay. So still you need to still have FCO and FCM. Now see at this joint, if you see, let's look at this joint D. This member FDO is perpendicular to the member FCD and FDE. Now we know trusses are axial force carrying member. So at the joint D, let me draw the equilibrium of joint D. Let's assume the force in the member FDE is in this direction, like it's tensile. So this is how I'm drawing it. So the like these are the three members at this joint FCD. So for the equilibrium of this joint P, for the horizontal equilibrium, FCD is equal to FDE and the force FDO has to be 0. Why it has to be 0? Because if we for the vertical equilibrium, like if I write summation of Fy is equal to 0 for vertical equilibrium, only force existing is FDO. There is no other external force or no other member. So this FDO, the force in the member DO is 0, or it is known as a zero force member. So the force in this member is 0. Similarly, if we consider, so this angle is 90 degree. Again, if you consider, uh, let me open my question. Uh, if we open, if we look at the dimension, see, this is this is 2 meter. So this is 2 meter, meaning this angle is like 45 degree. This is 45 degree. Again, if you try, so what I'm doing, I'm considering the triangle. Let me expand and draw. I'm considering the triangle CDO and E. Here my point is this angle is 45 degree. Even this angle is 45 degree. Meaning this is also 90 degree. If this is 90 degree, if I draw the equilibrium of joint O, so you have the force in member FCO, then FOE and FNO. And the force in the member, there is one more member OD, but the force in the member OD is 0. So even this force CO is a zero force member because these the member OE and OM, these are axial force carrying members. So the force will be equal and opposite, but for the equilibrium in this direction, let me call this Y direction. In this y direction, the only force existing is FCO, and there is no other force. So this FCO has to be zero force member. So in this diagram, FCO is a zero force member. Then the only three unknowns is FNM, FCM, and FCD. Then you take moment about point uh, A, take moment about point A and solve the question. Take moment about point A is equal to 0, and let's take clockwise moment to be positive. RAB will not appear in the equation. FNM will not appear. So FCM, and it is at a distance of 4 meters. Okay. And at the force point C, you have a force of 2 kilometers. And plus, so clockwise is positive. So this is anti-clockwise. So this is minus. Clockwise is positive. So plus 2 into 4 is equal to 0. So FCN is equal to 2 kilonewton. Positive means it is tensile in nature. Okay. Now, so what is done? FCM is done. Now you have to calculate FCT, force in the member CT. How do I do it? I again take a summation of point about, okay, if I take summation of moment about point M, then this F and M will pass through point M. So moment due to F and M will be 0. FCM will also disappear. So the only thing that will exist is FCD. So consider the moment about point M to be 0. Then let's consider positive clockwise moment to be positive. So RAV into what is the vertical distance between point M and RAB is 4 meters minus, again this 2 kilonewton force is also passing through point M, because like the line of action of the force 2 kilonewton is passing through point M, so that is also 0. So minus FCD, and it is at a distance of how much? 4 meter into 4 is equal to 0. So FCD is 5.625 kilonewton. So FCD is nothing but RAV. And how much is RAV? 5.625 kilonewton. It is also positive, so the force is tensile in nature. One more part to this question. You have to identify you have to identify the number of zero force members in this truss. I just explained the concept of zero force member. So, a second part to this question is this was part one, and part two is find the number of zero force members in this truss. So in this truss, you have to find out the number of zero force members. So uh, for demonstration, I just showed that. Okay, let me copy this truss. It's fine, otherwise I'll draw it once again. Now I want you to find out the number of zero force members in this truss. So what will be your what will be the logic? Again, I'll explain the logic. Let's consider the joint D. At the joint D, there are like three members, CD, DE, and DU. Now, the truss member are axial force carrying members. So the force in and the so this equilibrium of this joint D for the horizontal equilibrium, FCD is equal to FDE. The force will be equal in magnitude and opposite in direction. But for the vertical equilibrium, there are no external force acting at that point. So the only force is the force in the member DO, which is equal to 0. So I'll draw for the sake of completion, I'll draw the truss once again and we'll mark the zero force member in this truss. E, F, G, H, I, J, K, L, M, N, O, P. This distance is 4 meter, like 2 meter and 2 meter. And these panels are all equal in length. So 8 panels, each of distance 2 meter. This is pin support. This is roller support. This is, you at the point C, you have a force of 2 kilonewton. At point E, you have a force of 5 kilonewton. At F, you have a force of 3 kilonewton. At G, you have a force of 2 kilonewton. We have already identified that this is a zero force member and this is a zero. Similarly, if you look at equilibrium at point B, AB and BC, like they are collinear, the forces will be equal and opposite. So this will be a zero force member. Now again at the point N, AN and NN, the line of action is same. So NC will be a zero force member. Similarly at the point H, GH and HI, they are collinear, the forces will be equal and opposite. So GH is a zero force member. At the point J, uh, KG and HI, the forces will be equal and opposite. Again, from the concept of equilibrium. So GH will be, this is all possible because these angles are 90 degrees. And from where did I get that? That comes from the geometry. Because the length of this panel, one panel AB is 2 meter. Suppose this is A, B, and N, and this height is 2 meter. So this is 45 degree. So this has to be 90 degree. From there, it was seen uh, that these angles which I just marked are 90 degree. Then again, this is a zero force member because at this point L, this LM and LK, the forces will be equal in magnitude and opposite, and this will be a zero force member. So these are the zero force members in the truss. So these are like under this loading condition for this set of loads. So there are 7 zero force members, 7 zero force. Fine. Now, let's pick up a different question. We did quite few questions today. Almost, okay, 8 questions have been done. So let's move on to the next question. That is question number 5. So the thrust is similar to this thrust in question number 3. Okay. So in this question, this is A, B, C, D, E. So A, B, C, D, E. Let me 2 meter, 2 meter, and 1 This is 2 meter, this is 2 meter, and this is 1.5 meters. Suppose this is the truss which has been given in the question, and you have to find out, it is mentioned in the question, that all the members have a uniform mass of 8 kg per meter, and under that condition you have to determine the force in the members BC and DE. So let us consider this uh, as a question of self-weight. Suppose the truss, all the members have equal cross section, and they have a uniform mass of 8 kg per meter. all members of the trust. Usually, we don't consider the self-weight in a question of trust, but in I am giving you a question. All members of the trust have a uniform mass of 8 kg per meter. You have to determine the force in the members. Determine the force in the members BC and DE. So you have to calculate the force in the member BC and DE and no external forces acting on the system. So I'll give you the options as well. 118 Newton compression, 857 Newton, sorry, tension. Then 118 Newton tension, 857 Newton compression. 857 Newton compression, 118 Newton tension, 857 Newton tension, and 118 Newton compression. So when self-weight has to be considered, what was discussed in the class, you lump the, suppose uh, the weight is 8 kilonewton per meter, and suppose the load is 8 kilonewton per meter, and suppose the length of the member is L. So what is the total mass? Like 8 kilonewton per meter into L meter, it is 8L. Now you can lump this 8L force at the two ends of the members. Like 50% of the weight will be lumped at one node and 50% of the weight can be lumped at the other node. Like this was how you can proceed in this question. So let's lump the forces so that will be clear. So A, B, C, D, E. So this is 2 meter, this is 2 meter, this inclined length is 2 meter, this is 2 meter, this height is 2 meter. So how much is this inclined length? 1.5. You can use the Pythagoras theorem and calculate it. So this is 2.5 meter. So I'll just get my calculator plus 4 minutes. I'll just be back. So let's consider the member. Okay, I'm a bit confused in this question. Um, okay, let's consider the member BC. Length is 2 meter. So 8 into 2, 16. 16 kg per meter. So let's convert it into weight. So 9.81, 156 newtons, equally divided into 2 is 78.48 newton. So here and here it will be lumped equally. So 78.48, 78.48, and here all this is in Newton and Newton. So it is 8 kgs per meter. So 8 kg into what is 8 kg is the mass. 8 kg per meter is the mass per unit length. Convert it into the weight per unit length, and then multiply it with the length of the member, and then lump the forces equally on the two ends and get the weight. Similarly, for you will have contribution at this node from the member AB, BE as well as BD. So AB is 2.5 meter, is 2.5 meter in length into 8 into 9.81 divided by 2. So this is like 98.1 and 98.1. It is divided. So then consider BE. So length of BE is 2 meter. So again it will be length 78.48, and in this direction 78.48. Then consider BD. BD is similar to AB. So here you will have 98.1 and here you will have 98.1. Then consider member. So all the contribution in the member B has been considered. So sum them up 78.48 plus 98.1 plus 78.48 plus 98.1. So it comes out to be hold on for a second. How much is this height? Then get it meter to meter. Sorry, I did a mistake. Let's first consider the member. This is fine. 78.48 contribution from the member BC. Basically, all the contribution at the joint B, you will have contribution from the member AB, BC, BE, and BD. From BC, the contribution is 78.48. Now, take the contribution from the member BD. BD length is 2 meter. This height is 2 meter, this height is 2 meter, so 4 plus 4 to the power 5. This is 2 point, the BD is 2.828 meters. So comes up into 8 into 9.81 divided by 2. So 100, and it comes out to be some 110.98. And again 110.98. So this contribution is from the member PT, 110.9. Then consider the member PE. The length is 2 meter. So the contribution will be 78.48. 78.48. Now consider the member AB. if you consider the length is 2.5 into 8 into 9.81 divided by 2. So this is 98.1 and plus 98.1. If you add them, you will get 78.4 plus 10.92. So it is some 366 newtons. 366 newtons. So this comes out to be drawing B is done, drawing C is done. Now at joint A, you have considered the contribution of AB. From AE, what will be the contribution? 1.5 into 8 into 9.81 divided by 2. So plus 58.86, which comes out to be 150, around 156.96 Newton. Then plus you will have 58.86 plus contribution from the member ED. ED is 2 meters in length, so the contribution will be 78.48 and 78.48 here as well. So if I draw this diagram clearly, what will be the total force? Here it is 78.48 at joint C. This is B. This is A. This is C. This is A. So at joint B, I had already calculated 266 newtons. At joint B, I had added this is 156.96 newtons. At joint, let's add 78.48 into 2 plus 58.86. 203 and G, and since no external force is acting, but like this is the external force acting, you still have the support here, right? Don't forget the support. And joint B, it is like 110.98 plus 78.4. There's 189.5. Now, under this force, you can simply calculate the force in the member BC and this is straightforward. Either you can use method of joint or you can use method of section. See, like, see, quickly I'll here, like, for a change, let's use method of joint. So let's pick up joint A. Let's do summation of force in the vertical direction to be 0. This is my positive x direction, this is my positive y direction. So FAB into its component in the vertically upward direction. So this is 2 and this is 1.5. So this into let's consider this angle to be as theta. So FAB into sin theta minus 156.96 is equal to 0. Here FAB will come out to be 96 Newton positive, that is in 10. So in this way, if you go on proceeding, you will get the answer. So, I think so. This question is straightforward. I'll directly give you the answer. Here, the calculating the load was little tricky, so that is why I explained it. Okay, and let's try doing a different question now. time, if you have any question in the assignment or the content which has been covered in week 1 or week 2, you may ask your question. So, kind of covered all the questions which I had. But if you have any doubts, you can ask them. Okay, if you don't have any question, we can quickly do a question on friction. So the diagram of the question is like this. This is your coordinate axis. Then let this side be 3, this side be 4, this side be 5, this angle is theta. And you have a shoe on this inclined surface. I'm trying to draw it. And you are applying a force in this direction. Like it's written that a block of weight W rests on an inclined plane, which makes an angle theta is equal to tan inverse of 3 by 4 as shown in this figure. A force P parallel to the x-axis is applied to the block and it is gradually increased from 0. When P reached the value 0.4 W, the block begins to slide. You have to find out what is the coefficient of friction between the block and the inclined plane. So for the sake of the notes, I'm writing down the question as well. The block of weight W rests on an inclined plane, which makes an angle which makes an angle theta of tan inverse of 3 by 4 as shown. The force P parallel to the x-axis, parallel to the x-axis is applied to the block, is applied to the block and gradually increased from 0. And gradually it is increased from 0. When this P reached the value of 0.4 W, the block begins to slide. The block begins to slide. What is the coefficient of friction? What is the coefficient of friction between the block and the inclined plane? Between the block and the options are F is equal to 0.6, F is equal to 0.7, 0.6, 0.7, 0.8, and 0.9. Fine, I will not write down the. You have to find out the coefficient of friction. Try drawing. Basically, try draw the free body diagram of this block. Then you'll get your answer. Try drawing the free body diagram of this block, and that will help you in solving this question. The time is limited. Let's draw the free body diagram. And I am drawing, looking at this block, like I'm projecting this block on the YZ plane and I'm drawing it. Since I'm projecting it on the YZ plane, the inclination here will be perpendicular 3, horizontal 4, inclined 5. Okay? Then the block is sitting like this. The weight is acting in the vertically downward direction. Normal to the surface is Fn, and let's say the friction force is getting applied in this direction, Ft. Then I want to calculate the value of Ft and Fm. What can I do? I can, let's say, consider a new arbitrary axis like y dash and z dash and y dash. These are my arbitrary axis along the normal and the tangential direction. Along the normal direction is z dash, and along the tangential direction is like y dash. And now let's do summation of f y dash is equal to 0. Then it will be minus of ft, and then you have to take the component of the weight will be w into sine theta is equal to 0. So ft is equal to, how much is sine theta? Sine theta is 3 by 5 into w. So this ft we have calculated. Now I want to calculate Fn. For that I will do summation of fz dash is equal to 0. For that Fn plus Fn plus weight is in the z direction, so minus W cos theta is equal to 0, right? So Fn is equal to W 4 by 5. Now we have to find when T, uh, how my T force is in this direction. Then what will I do? So this was, we are considering the friction in this direction. So now project it in the XZ plane. If you project it in the XZ plane, that is the axis is like X, Z axis, X axis. Here you are applying a force P, and here the friction is Fx. So by equilibrium in this direction, Fx is equal to P. Means Fx is the is the restricting force in this direction. What will be the total friction force? The total friction force, which I am calling Fs, it will be resultant of this Fx and this Ft. So Fx square plus Ft square, and this Fx and Ft are perpendicular to each other because they are they are friction on the two planes, we can say. These like Fx is lying in the plane xz, and Ft is lying in the plane zy, and the planes are perpendicular to each other, so the forces are also perpendicular to each other. So this will be the as a resultant friction force. Now we know that ft ft is 0.6 into W. And what is Fx? Fx is equal to see, when P reaches the value of 0.4 W, the block begins to slide. So, or in other words, Fx is equal to 0.4 W. So plug in 0.4 W whole square plus this under root. So this comes out to be 0.4 square plus 0.6 square, e power 0.5. So 0.0.0.7 0.72 W. Friction force is nothing but the SS, the coefficient of friction, into the normal reaction. Normal reaction is 0.8 into W. I'm using this number is equal to 0.72 into 9, sorry, 0.72 into W. So coefficient of friction comes out to be this divided 0.72 by 0.8, 6.9. Is this question clear? Okay. Assuming it's clear. Any doubts in the assignment which has been given in the week 2, as well as assignment 1? I believe the solution for assignment 1 has been provided. So if you have any doubts in assignment 1, or any question in assignment 2, like you have not submitted it, so we can't discuss the entire solution, but if you're stuck at any place, we can discuss that. if you have no doubts, then like this is what I wanted to cover today. So basically, uh, yes, uh, you may unmute yourself and ask your question.
Hello. Yeah, ma'am, I'm not able to understand this problem, last problem which you solved.
Okay, like, did you
Yes,
understand the
We are, we
question?
are, we are working in, first we are working in a ZY plane,
Yes,
and then we have shifted to XZ plane. So in ZY plane, we have arrived at the tangential component and normal component.
yes.
And then I'm not able to understand what is this fx and ft.
Like, uh, basically, uh, your friction force, the friction force will be on the plane. If you project the plane, it will be the x. Your force will be lying in the xy plane. But it will that friction force will be composed of you can say two components. So that is why I am considering, how do I explain this?
Actually, the I think what you arrived at is the in the plane FYZ only, and we are referring to it in XZ plane. The
Like,
resultant, what FF, what we have arrived, resultant. I think it is in YZ plane only, but we are referring that in XZ plane.
suppose if I consider the if I think in terms of let's say vectors, so I have a friction force along the z along this direction on the YZ plane. Um, Again, if I break it in the if in the terms of vectors, it's getting complicated. So if I try to draw it, so like something on this plane, on the inclined plane I'm trying to draw. So this is FT, this is FT, and in this direction as well, you have friction Fx. So what is your resultant friction? This is what I'm referring by Ff. Your resultant friction will be something in this direction.
Okay.
Something
FF.
mm, like the explanation is not very clear, but like you can visualize it
Yeah, I got it.
as
I got
the
it.
friction on the
And,
inclined surface.
okay. And then how this fx is equated to p? We are finding p. Okay.
Like when you are, uh, suppose you are looking at the block from this direction. So then this force P is getting, like basically you are summing, writing down the equilibrium of the block in the direction X. Then what are the forces appearing? P is the force and Fx is the force appearing on the body. Like the force exerted on the body is P and Fx, and they need to be equal. Similarly, if you view the block from, let's say, this direction, then what are the forces acting on the body? See, W will act in, okay, this might be a confusion, that when you are looking at the block from this side, that is, let's say, direction 1, weight is still acting on the block, but that is getting balanced by the normal reaction. Okay, now I
How
get
we
your
are
confusion.
how we are arriving at these values of zero point 0.4 W
Yeah,
and zero point 0.6 W?
now I get your okay, I will have to look at this question. Even I'm getting confused. I think so.
Point 6 we have worked out, FT we have worked out, but FX
Yes.
I don't think where it is worked out.
No, this
FX.
FX is suppose I think so. I messed up the question here. Suppose when you are looking at the block from this direction, this force P is in the x direction, Fx is also there in the x direction, but in the z direction, you will also have W. You can't leave out W,
Yeah.
but the W has been, so you will have a normal reaction here as well. So is this normal reaction related? Uh, then this weight will be equal to the normal reaction in this direction. And okay, I'll look at this question. I don't think so. I think so. There is a problem in the solution.
Okay. Yeah.
Yeah. Any other conclusion? Okay. If there are no other doubts, I'll close today's session and I'll try to clarify this doubt as well in the next days. Thank you for attending the session.